Hello everyone. Today we are in the chapter 5 and today our discussion topics is analog transmission. In analog transmission we need to transform the digital data to the analog signals. Here from digital to analog conversion stands for digital data. By modulator it will transform this digital data into analog signal and then the demodulator again generates the digital data. The types of digital to analog conversion. Here are amplitude shift keying, which is known as ASK, the frequency shift keying, which is known as FSK, and the phase shift keying, which is known as PSK, and all are connected with the quadrature amplitude modulation, which is known as QAM, which all are in the digital to analog conversion. First of all, we need here to know about the bit rate and bound rate. Bit rate, data rate sometimes called bit rate, signal rate sometimes called as bound rate. The formula of calculating the bound rate is given below. Here are some mathematical notations for your practicing. You can have a snap of this one and practice at home. Now the bandwidth. The bandwidth for analog transmission to the digital data proportional to the signal rate execution for the FSK, which difference between the carrier signals and needs to be added. What are the carrier signals? The analog transmission, the sending devices produces a higher frequency signal that acts as a base of the information signals. What are the ASK, which is amplitude shift keying? In this ASK we have binary ASK, and binary ASK, which is known as BASK, is on-off keying or OOK. By this diagram we can easily say that when the one segment is eliminated, then the amplitude is having the frequency, and if the signal is 0, then it does not have any frequency. But when another it is 1, it will have the frequency, and when it is 0, there is no frequency. So this is known as the binary ASK because that depends on 0 and 1. Now the bandwidth for ASK, the formula is used for counting the bandwidth for ASK. Here D is the value between 0 and 1, and S is for the signal rate and B is for the bandwidth. Here is again a mathematical notation. Now the multi-level ASK, which there is the more than 2 levels. We can use this for 4, 8 and 6 and more different amplitudes. Here in this case R equals to 2, 3 or 4 and so on. Alternative things are not important with the pure ASK, and it is implemented with the QAM, which we have declared first in this section that QAM is for that section. Now the frequency shift keying, which is FSK. The frequency shift keying depends on the frequency where the carrier signal varied from representation of data on both peak amplitude and phase. Remainder consists of all signal elements. By this diagram of binary FSK we can say that here when the input is 1, then we have the frequency, but when it is 0, the frequency have distance. But when we have again 1 and 1, the frequency is okay, but when we are getting 0, the frequency again create distances. Here is the mathematical notation or formula for finding the bandwidth for BFSK. Here are some mathematical notation for them. Now moving on, we will have the phase shift key. That means the shift keying is depending on the phase. If we see the diagram, we can easily understand that when the input value is 1, then the frequency is okay, but when it is 0, the frequency is going on the reverse direction. But when it is again 1, the frequency is okay. Then when the input is 2 continuous 1, the frequency is obviously okay, but when it occurs the 0, then the frequency goes in the backwards. This is known of phase shifting. By here we use the binary phase shifting, which is known as BPSK in this diagram. Here are some again mathematical notation which are quite important for your examinations. You can practice them at your home. Constellation diagram. A constellation diagram can help us to define the amplitude and the phases of signal amplitudes. Particularly when we use the two carrier, one in phase and one in quadrature, the diagram is useful when we are dealing with the multi-level ASK, PSK and QAM. Here is the diagram of concept of constellation diagram. Here we have the amplitude, and in this section we have the phase. Here is the length of the amplitude. In this section we can see that in ASK we have only 0 to 1, but when we have in the PSK section, which depends on the phase, we have two phases, 0 and the 1. Here middle layer is neutral, but here middle is 0. But when we are in the QPSK, when we have 4 quadrants, they are 0 0, which means the 0 section, then the 1 section, then 2 section and the 3 section. Here are some description about those diagrams. You can go through them. Now, quadrature of amplitude modeling. Here we have 4 QAM. Here we have 4 points that is denoted as 4 QAM. In B section we have again 4 QAM, but in this section we have covered many other subparts of this section. In C we have again 4 QAM, but this is in one section. Here we have 16 QAM. For this, each of section contains a 4 QAM, so 4 times 4 becomes the 16 QAM. Here are the description of them. In figure A shows that 4 QAM scheme. First, 4 different signal elements of types which are unipolar. In the figure B, there are polar NRZ. That means those dependents on the pole sections. In the C section, we have used a signal with two positive level modulation of each level with two carriers in this section. And in section D, we have show 16 QAM constellation of signal with 8 level with 4 positive and 4 negative. Here 4 are positive. In this section, this we have 4 positive and 4 negative sections with 8 levels. Here are the difference between ASK, FSK and PSK. You can have a snap of this one and go through them. The basic difference is ASK is simple, but in FSK it is medium level and PSK is very complex. Noise immunity is very low here in ASK. In FSK it is high, and in PSK the noise immunity is again high. There are difference between their formulas. The ASK it depends on the amplitude, FSK depends on the frequency, and the PSK depends on the phases. The advantages and disadvantages are given here. You can go through them. This difference between and advantages are very important for your exam question point of view. So you must have a snap of this one. Now here are some previous year questions which you can get from the slide. I will give the link of the slide below. That's for today. Thank you.